Hey, what's going on, guys? Komakikenzi here. In this video we're going to be implementing a method to generate moves for a current given site to move in our tic-tac-toe game. So let's actually start by opening the terminal in the current working directory and by typing python 3 tic-tac-toe.py. So here is the output from the previous video, and now where to make this? Well, probably just right below the isWin method. Here we want to generate moves, so def generate moves, and it only takes the self instance. That's kind of it. And again, it's a bit tricky regarding the terminology of how to call this. Well, generate moves is something from my chess programming backgrounds. If we're talking about the Monte Carlo research terminology, then it's not called moves. It's called kind of board states. So what we would be having within our move tree is the board states. So that's well at least that is how that is called in the Monte Carlo research algorithm terminology. So well, probably I will call this generate states, and here just to give an idea, so generate legal moves to play in the current position, like this. So just to give you an idea, but yeah, probably I will leave this generate states name. And again, like first let's define states list, and in the parentheses I just want to say, so this is like a move list, like available actions list of available actions to consider. Okay, and probably let's call this list actions, and this would be the type of list. And now the logic is very simple. We just need to loop over the board squares. So I can simply say like for so we need to loop over board rows, and I say for row in range of 3, and then we need to loop over board columns and for col in range 3 again. And now the only condition to check the move legality, basically, we need to make sure that we're making this move on an empty square. So we need to make sure that current square is empty. So we can simply say if self.position indexed by row and column is equal to self.empty square. In this case, we want to generate, well, not generate, let's say append available action and slash board state, because what we literally would be appending is the new instance of the board class. And this is incredibly important to understand because when it comes to Monte Carlo research, it's all a matter of the instances of the board. So every time we're creating a new node in the game tree, every new node has the instance of the board of the tic-tac-toe board class. That's quite a pretty important thing to consider. So append available action or board state to action list. So here we can simply say actions.append, and now I want to call the self.makeMove function, and just want to make sure the order is row followed by the column. Okay, row followed by the column. So we'll now make move here, make move, and I'm passing row and column. And now it's a very important thing. What would it be returned by this make move function? So we just go to this make move function here, up here. First, it will create a new board state for us. Then it will adjust the position using the coordinates that we've provided to make a move on. And it would be player whatever character is available at the player 1 at the moment. So this might be either cross or not. Okay, and also it would swap the players after. So and eventually it would return the new board instance. And this new board instance would already have the swapped players already. So kind of changing the side every time we're making the move. So at the very end, this list of actions is something that this is actually the list of board class instances, where every single instance would be having adjusted position inner position field in the way so that where the coordinates within those coordinates we've provided, we would be having the corresponding character that would be representing player 1, either cross or not, depending on what actually player 1 would be equal at the moment of generating new moves or new board or new list of board instances. So eventually we want to return the list of available actions, and I just want to specify that these are actually board class instances. So from the game perspective, it would be better to say, like, from the Monte Carlo tree search perspective, this list is treated to be the available actions. From the Python programming perspective, this list should be called the list of board class instances, because this is literally what would be within these actions. And from the game perspective, from the game itself, from the perspective of the game itself, it would be the list of moves, basically. So 3 different names, but they all have the same idea behind it. So we call this actions, basically, just from the Monte Carlo research perspective. So here I just want to return these actions, and it's very important in regards to Monte Carlo research to have these actions as the iterable, because by saying iterable, I mean like a list that we can iterate over. And it's incredibly important to have this iterable in return, because when we will be implementing the Monte Carlo research itself, we'll need to loop over these actions, and if it's not iterable, we won't be able to loop over it. So I hope this is quite pretty clear. And again, like obviously, we would be creating a single node within the game tree, and we would be assigning every single action or the board class instance, which is the element of this actions list, would be assigning this to a particular tree node in a game tree when it comes to Monte Carlo tree search. Okay, so I think this is it, and now we can already go for some sort of a testing. So let's generate, let's call it actions, available actions. So let's say actions equals board dot generate actions, like this. And now we can loop over generated actions. So for action in actions, and assuming that every action is actually the board instance, we can just print it. So we want to print action, or to be precise, print board state instance. So print and action. Okay, so let's try to compile and run to make sure it works. Okay. Did I misspell something? Oh, generate states. Yeah, it's better call this generate states. Yeah. Okay. And here is the list of all the legal moves we have basically. So assuming that we already made a move using the cross, now it's obviously not to move. So the next move would be the not. So here all the possible moves that can be made from the starting position. And again, like later on, all this board states would be assigned to a specific tree node in a game tree in the Monte Carlo tree search. Okay, so just to give a little bit more clarity to this sort of stuff, let's actually make this is called take action from the Monte Carlo tree search algorithm perspective. From the Monte Carlo tree search algorithm terminology perspective. So take action, or this is actually kind of like make move on board. So in order to make the actual move on the on the tic-tac-toe board, sorry, we need to say board equals and well, actually, as far as this kind of action is already a board instance, we can just assign it. I was just thinking now that we could have actually tried to create a new board state to make a copy, but that seems to be unnecessary. So we can simply say board equals to, and let's say actions, and let's take the very first one. So we'll make this the very first move, like in the top left corner, and print updated board state. So I just want to print made move, and the move would be like, I don't know, 1 1. So I mean it means like row, or maybe even like column and row. Well, okay, I don't really want to confuse you guys. Let's say first generated move has been made on board, and just print the board. And well, probably we can get rid of this just for clarity. Okay, we didn't print. Okay, so this is the initial board. So yeah, let's say print. This is initial board state, and print the board. So we have this initial board state. This is how it looked like. And then first generated move has been made on board. So you remember, like, we have the list of moves. So here is the first generated move. And now it is made on board. So we did assign board to actions 0. So this is known as a take action. So if you just reading some literature on Monte Carlo tree search, there is a term called take action. So this is what we doing to take the actual action here. And again, like when we did take this action, it will now be generating the moves for this newly updated board state. You'll realize that now we would be generating knots instead of crosses, because it's not to move now. And it would be generating the knots only on those squares that are currently empty, so it won't be generating the knot on the very first initial square. Okay, so let's generate available actions again, and assuming that we already have the board being updated, so here we generate available actions for let's say after first move has been made, and again, like, well, actually I think that it would be nice to have this loop here in particular. So now we can loop over generated actions again and print action. And okay, hold on a sec, I don't understand why. Hold on a sec, guys, I just feel a bit confused why we don't see but yeah, actually this seems to be right, because when we generate moves, okay, I'm sorry guys, my cat was trying to eat the cookies. They were laying on the table, I'm sorry for that. Okay, so let's get back to our tic-tac-toe. So made the first move on the board. Yeah, this is actually correct, because we're printing the pure actions, and the first action starts from here, not from here, because here we already have yeah, we already have our move being made. So in order to print this in a more proper way, so to see the X being available, we need not only print the action, but we actually need to take the action and then print it. So take, so just to make it more visible, basically. Okay, so take an action, so say board or hold on a sec. Well, I can create a new board instance, and no, it's not. Okay. I didn't when I was initially developing this, I didn't even think about this sort of a demonstration. Okay guys, hold on a sec, I just need to figure out how it's better to be done here. Okay guys, I'm sorry, I found a horrible bug in the make move function though. So I've been talking about the importance of inheriting from the previous board state in the initial video in this series, while describing this part when we're copying the dictionary of the inner states from the previous state, but actually I forgot to do this inheritance in the make move function, and I didn't even provide the wrong commentary here. So we actually don't need to create the new board. We need to make sure that we actually pass in the self argument so it means that we're creating the new board instance from the current state instance that inherits from the current state. And in this case, the newly generated move would also contain the previous move that was made on board. And I was so confused because when I was watching this generated actions, it didn't contain the previously made move. Okay, so let's actually move from the very beginning here to make sure it's working. Yeah, now it's working fantastically well. You see, like we're already generating the next move while we haven't the first move being available on the board. So again, I just want to quickly walk through this to make sure that the understanding is correct. So hold on a sec. Okay, what am I printing? Oh, this output. So sorry guys, I was altering. I was debugging the generate states, so I've added this line here. Let me get rid of this at the moment. Okay, so just to give it clear. So now when we again, let's walk through the process from the very beginning. So we create a board instance and print it. Then we generated the actions and taken the first action available and print the board with this newly available action, which is this one. And now the idea is that every time we're making a move, we need to make sure that we're making it not on the new instance of the board, but on the current existing instance of the board. Okay, so let's say when we make when I was implementing that make move in the initial video, I just forgot to do that, so I'm sorry for this really. So now we actually print the actions, well, let's say print the actions 0. See, like we already have that a newly generated action does contain the previous it's based on the previous board state on this one. So literally every new action generated here would already be containing this previously made move. And now, well, let's say that we take so hold on a sec, I'm just wondering. So okay, so we took this action 0, 1, 2, 3. Let's actually take the action number 3. Okay, and if we now want to generate another move kind of sequence of moves, so generate available actions after this move has been made. Okay, and here we take action, and now let's actually loop over generated actions. So for action in actions, print current action. Now we already have all the previous moves being made, and again, like it was the previous iteration was generating knots, and now in this current iteration it already generates this crosses. Again, like starting from what position? Oh, so this was probably for some fun. Okay, hold on a sec. Hold on a sec, I can't understand why. Why it seems like it generates for this sort of a position rather than this one. Sorry guys, I feel totally confused. generates correctly, but I'm just wondering why does it generate for this position? Oh, I just print the actions free. I didn't actually take that action. Yeah, I take the action 0. So if I just take the action 3, and here I just want to print the board. Yeah, now it's clear. Okay, so yeah, now this is correct. So here let's print generated moves states. So yeah, now this is correct. So this is the position that we have, and this is the position we're generating moves for. So starting from here, 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 here. Yeah, this is right. So yeah, I think at this moment we can already claim that our move generator works quite pretty nicely. So again, like I just want to emphasize one last time this bug that I've made in the first coding video, at least in this series. So when it comes to this make move, we need to make sure absolutely that we creating the new board not from scratch, but using the self, and this self stands for the current board state. So say we already did make this kind of cross or not, so if just get rid of this, you see like the newly generated moves it does create this newly generated moves, but they don't contain any previously made moves. So in order to avoid this, we really need to make sure, I already lost that here, that we creating this new board instance that inherits from the current state. So very important stuff. In this case, we have all the moves previously done on the tic-tac-toe board being available. Okay guys, so this is it from my side. I hope you enjoyed this. I hope you've enjoyed the tutorial. I'm sorry for making this horrible bug here, but now it's fixed. So I'll probably now add some commentary below the video where it has occurred actually, so to avoid the possible confusions for those who would be following this tutorial. Okay guys, so I think this is it, and in the next video we're gonna be writing the game loop basically. So first we'll start with the game loop where a user would be able to play versus kind of another user, like human versus human mode, and then when we'll implement the multi-carrot research algorithm, we'll alter the game loop so it would be searching for the best move in the current given position and making it on board from the computer's perspective. So this is it, until the next time, and take care.